In this project, I will teach you how to perform exploratory data analysis, EDA, using Python on a real-world sales dataset. The objective of this project is to help you understand how raw business data can be explored, cleaned, analyzed, and interpreted using Python in a structured and logical way. This project is designed especially for beginners and intermediate learners who want to build strong fundamentals in data analysis and confidently explain insights during interviews, presentations, or video content creation. EDA is one of the most important stages in any data-driven project. Before building dashboards, applying machine learning models, or making business decisions, it is crucial to understand the data deeply. In this project, I will walk you through how to inspect data, understand patterns, detect anomalies, and derive meaningful insights using Python libraries that work smoothly in Google Colab. Dataset Introduction. The dataset used in this project is candy_sales_dataset_200_rows_corrected.xlsx. This dataset represents sales transactions of a candy manufacturing and distribution business over 3 different years. Each row corresponds to an individual sales order placed by a customer, and the dataset captures important operational, financial, and product-level information. This dataset is ideal for EDA because it includes time-based data, order dates, years, months, categorical variables, country, ship mode, factory, division, numerical variables, sales, units sold, cost, profit, business metrics useful for profitability analysis. The dataset contains 200 rows, making it large enough to identify trends while still being easy to analyze and explain step by step. Column-wise explanation. Now, let's understand each column and what it represents. Order date. This column shows the exact date on which the customer placed the order. It is useful for time-based analysis such as trends, seasonality, and year-over-year comparison. Year. This column represents the year extracted from the order date. It helps in grouping and comparing sales performance across different years. Month. This column indicates the month of the order. It is helpful for identifying monthly trends, seasonal spikes, or slow periods in sales. Customer ID. This is a unique identifier assigned to each customer. It allows us to analyze customer behavior, repeat purchases, and customer-level performance. Country. This column shows the country where the order was shipped. It helps in geographical analysis and understanding market performance by region. Ship mode. This represents the shipping method used for delivering the order, such as standard class, first class, or second class. It can be analyzed to understand logistics preferences and cost implications. Factory. This column indicates the manufacturing unit or factory where the product was produced. It is useful for operational and factory-level performance analysis. Division. This represents the product category or division, such as chocolate, sugar, or other. It helps in understanding which product categories drive the most sales and profit. Units sold. This column shows the number of units sold in a particular order. It is a key metric for volume-based analysis. Sales. This represents the total revenue generated from the order. It is one of the most important financial metrics in the dataset. Profit margin. This column shows the profit margin percentage for the order. It helps in understanding pricing efficiency and profitability. COGS. This represents the direct cost incurred to produce the goods sold. It is critical for profit and cost analysis. Gross profit. This column shows the actual profit earned from the order after subtracting COGS from sales. It is a key indicator of business performance.
Python EDA code with line-by-line explanation, Google Colab friendly. Step 1. Import required libraries. This line imports Seaborn, a visualization library built on top of Matplotlib that helps create more attractive and informative charts. Step 2. Load the dataset. This line reads the Excel file and loads it into a Pandas data frame called df, which is the main object we will use for analysis. This line displays the first 5 rows of the dataset so we can visually inspect the structure and values. Step 3. Understand dataset shape and structure. This line shows the total number of rows and columns in the dataset, helping us understand the dataset size. This line displays all column names, which helps us verify the available fields for analysis. This line provides detailed information about each column, including data type and non-null counts. Step 4. Check for missing values. This line checks each column for missing values and shows how many null values are present. Step 5. Statistical summary of numerical columns. This line generates descriptive statistics such as mean, minimum, maximum, and standard deviation for numerical columns. Step 6. Convert date column to date format. This line converts the order date column into a proper data time format so time-based analysis can be performed. Step 7. Sales trend by year. This line groups the dataset by year and calculates total sales for each year. This line displays the total sales values for each year. This line creates a bar chart showing total sales for each year. This bar chart represents how total sales vary across different years, making it easy to identify growth or decline trends. These lines add a title and labels to the chart and display it clearly. Step 8. Monthly Sales Analysis. This line creates a line chart to show how sales change month by month. This line graph helps identify seasonal trends and months with high or low sales performance. These lines label and display the graph properly. Step 9. Sales by Product Division. This line calculates total sales for each candy division. This line creates a bar chart comparing sales across product divisions. This chart shows which candy division contributes the most to overall revenue. Step 10. Profit Analysis. This line calculates total gross profit generated by each division. This line creates a bar chart to compare profitability across divisions. This graph highlights which product categories are the most profitable. Step 11. Country-wise sales distribution. This line calculates total sales per country and sorts them from highest to lowest. This line creates a bar chart showing sales contribution by country. This chart helps identify the strongest and weakest markets geographically. Step 12. Relationship between sales and profit. This line creates a scatter plot to analyze the relationship between sales and gross profit. Right pointing backhand index graph explanation. This scatter plot shows whether higher sales generally result in higher profit and helps detect anomalies. Project conclusion. In this project, we successfully performed a complete exploratory data analysis, EDA, using Python on a real-world candy sales dataset. The primary objective of this analysis was to understand the structure of the data, explore key business metrics, identify trends, and extract meaningful insights that can support data-driven decision-making. By working through this dataset step by step, we demonstrated how EDA forms the foundation of any analytics or data science project.